Hello, everyone. I hope you're having a good day. We are almost done with Unit P. All right, we finally get to start learning some new stuff soon. This is the last video for our algebra review, and it's going to be going over kind of similar stuff to what we did yesterday with solving linear inequalities, but today we're going to be doing some special kind of inequalities. So we only have one page here, all right, so hopefully this does not take too long. We're going to be doing what's called compound inequalities, all right? Now there's two types of compound inequalities that we're going to talk about, and the first is called the OR, all right, or compound inequalities. So or compound inequalities will look like this, all right? If you look at your graph, what this is saying, all right, you've got two inequalities on the same graph, so that's where compound comes from, all right? If you think about compound words, taking two things and shoving them together. So how do we describe this, right? What does this look like? Well, what you do is you're going to look at each of your inequalities separately. So this is a dot at -4, and it's going to the left. So we're saying less than or equal to -4. So if we want to write this out, all right, we've got our variable. So we've got x is less than or equal to -4. So that's our first arrow. And then we're going to look at our second one, and this time we have a dot here. It looks like at 1, all right, it's an open dot, and it's going to the right, which means it's greater than 1. So we're going to say x is less than or equal to -4, or, right, or x is greater than 1. So when we're saying or, we're saying it's either of those two things, right? It could be less than -4 or greater than 1, but not in between, right? So this little section in between is the only section where our line is not touching any numbers. So the way that'll look in interval notation is you'll actually have to have two interval notations, one for each. So if you think about what we did yesterday, it's just taking that and then doing it 2 times. So if we want to represent this part of it, right, it's going all the way to the negatives forever. That's negative infinity. So we're going to have negative infinity up to -4, and since it's a closed dot, we're going to use a bracket. And then we also have, right, another one where we start at 1 and go up to infinity. All right, so we have two inequalities here that it takes to represent this graph. So basically, we're just skipping the section from -4 to 1. We're going from negative infinity up to -4, skipping this middle section here, and then from 1 to infinity. So that's the OR inequality. So we're going to solve two of these, two examples. So the first one, all right, you solve them separately, all right, is what you're going to do. So we just subtract 4. You know, it's really just taking what we did yesterday and saying, okay, you have just 2 of these problems to do, all right? X is less than or equal to 2. So that's our first inequality. So we can go ahead and put that on the graph, right? We can go ahead and put a solid dot at 2 and then make that go to the left, all right? Next, we are going to come over here. We're going to divide by 5, all right? That gives us x is greater than 7, all right? And now we graph that one. So this time, there's no line underneath, so we're going to have an open dot. At 7, it's greater than, so we're going to the right, all right? So here is our compound inequality. We have our first part, which is less than 2, our second part, which is greater than 7. So the way that we write that, when you're doing OR inequalities, you're always going to have negative infinity up to your first number, all right? So we've got negative infinity, and we're coming all the way up to our first number, and we're stopping. Then you've got 7, so your second number, so you're skipping over that, then you're starting your second number, and then you're continuing on all the way up until infinity. So that's how that one is going to look. Now we're going to look at a second one here. Again, you're pretty much just doing the same thing, all right? We need to solve for n. We're going to subtract by 7 on both sides, all right? Your solving skills have got to be good. If you can't solve, it's going to be hard to do a lot of stuff this year, all right? Now we're dividing by -9, so we're dividing by a negative, What does that mean? All right, don't forget, that means we've got our flip rule, so we got to flip from a less than sign to a greater than sign. So it's going to be n is greater than or equal to 1. So again, I'm going to go ahead and I'm going to put that on the graph. I got a closed dot at 1 because it's or equal to, and it's greater than, so I'm going to the right. And then here, this is easy to solve. Just subtract by 6 on both sides. So we've got n is less than or equal to -1. So now I'm going to put another closed dot right here at -1, all right, and it's less than, so I'm going to go to the numbers less than -1, which are on the left. So again, now an interval notation, right, where are we starting on the left? We're starting at an arrow that's going to the left, that's -infinity. And it's going all the way up to -1, and then it's stopping. So here's a bracket, all right? Now I have another bracket because this is another closed dot, and then it's going to the right. So we're going to go from 1. If an arrow is going to the right, that's to the positive number, so it's going up to positive infinity. All right? And so that would be how you do these problems. It's just taking two problems, doing them at the same time, putting them on the same graph. You have two inequalities, two arrows, and two intervals, if that makes sense. The other one that we're going to talk about is the opposite, all right? That's an and. So instead of it being either this or this right now, it has to satisfy both conditions, right? And that's going to look the opposite of or as well. Instead of arrows going away from each other, the two dots are just going to be connected by a bar, all right? So what this is saying is that x must be greater than -2, right, to the right of -2, but at the same time, it also has to be less than 5, right? So it only leaves this little section right here where your numbers can live. So how do we write that? All right, well, it'll be written as what's called a compound inequality. So actually, so the first way it could be written like we did above with the word and. So let's just say for a second. So we've got x is greater than or equal to -2. We could say that, and we could say it also has to be x is less than 4. So that's similar to how they were written above, right? But there's another way that you can write it. You can kind of smudge this together, all right? And the way that looks is we could say -2, right, must be less than or equal to x, which must be less than 4. All right, we're taking the two and we're just combining them, all right? And what this looks like, it's saying that x is in between -2 and 4, all right? And so the cool thing about this is this, right, method makes it really obvious what the interval notation is, all right? You're starting at -2, you're ending at 4, right? So you don't even need infinities here. You can just put 1 to represent both of them, right? Because it's starting and stopping. So there's no arrows, which means no infinity. So we're going to look at a couple examples here. The first one is going to be two separate inequalities with the word and in between them. So just like with or, we're going to solve these separately. So we're going to subtract by 3 on both sides. So that gives us 2x is greater than -12. Divide by 2. That's a whole number, or sorry, that's a positive number, so we don't have to flip our sign. -12 divided by 2 is -6. So I'm not actually going to draw the arrow here, but I am going to draw the dot, okay, because I know that there's going to be a open dot at -6. Now I'm going to solve my second one, so I'm going to add by 2 on both sides. That gives me 8x is less than 32. Divide by 8. All right, and I'm going to get x is less than 4. So now I know I'm also going to have an open dot at 4. And whenever you have and inequalities, all right, your line's going to be going in between them, okay? Because if we drew arrows, it would look like greater than -6, less than 4. So if your arrows are going towards each other, all right, that means we don't have arrows at all. We are just going to be drawing a line from -6 to 4 and stopping. Okay, and so in interval notation, we're starting at -6, parentheses, because we have an open dot, and then we're ending at 4, parentheses again. So this is saying all the numbers from -6 to 4, which is the same thing that's represented on our line. So the other way to do this would be with a compound inequality like this, a true compound inequality. And when you solve this, all right, you're solving both sides at the same time. So you're actually going to do it 3 times, all right? Anything you do in the middle, you must also do on both sides. People really, for some reason, want to get rid of one of their sides because they just want to have 2 sides. But if you do that, now you only have 1 dot, all right? It's a compound inequality, which means we're going to have 2 dots. So we're going to add 1 that cancels out that 1 in the middle, gives us -1 on the left, gives us 7 on the right. And now we graph this, all right? So you got to look at your symbols. We've got a equal to on both of them, right? So it's going to be 2 closed dots. So we're going to have a closed dot at -1. We're going to have a closed dot at 7. We're going to draw a line in between, and there we go, all right? A is from -1 to 7. Now when we do this, since they're both closed dots, we're going to have 2 brackets. So we're saying A exists for all the numbers in between -1 and 7. So that's what we're doing today, all right? I'm going to give you 2, and I highly recommend you to pause the video right now and try these 2 problems on your own, and then coming back and watching the video and making sure that you did it correctly before you go on to the practice. So go ahead and pause the video now. And so I'm going to go ahead and go over these, all right? So this is an OR, right? Which means we're going to solve both equations, or sorry, not equations, both inequalities separately. So we're going to add 5 on both sides. That gives us m is greater than 8. So I'm now going to go put my open dot at 8, all right? And we can just draw a little arrow to the right because we don't have that much room. Now on this side, we're going to do the same thing. We're going to solve. So we're going to get rid of our normal number first. So we're going to subtract 7. That gives us -5m is greater than -35. Now we have to divide. Now again, I hope you guys did this when you solved it. We're dividing by a negative, right? So it's going to have to flip. M is less than 7, right? -35 divided by -5, and negative divided by a negative is a positive. So we're actually going to have another open dot at 7. So look how close these dots are together, right? Except this time we're less than 7. So we're going to draw that arrow to the left. So we're really representing almost all the numbers, all right? You might even think we're representing all the numbers, all right? But we're not, because remember, there are a bunch of decimals and fractions there in between 7 and 8. So we're going from -infinity up to 7, and then we're closing, right? Because we got our jump. We're picking back up again at 8, and we're going to infinity. So we've got -infinity to 7, and then 8 to infinity. Last question. This is an and, all right, compound inequality. Ors can never be written this way, all right? So if it's written this way, it's got to be an and. So we want to solve this. So we're going to add 1 to all our sides. Cancels that out, so this becomes -2 is less than or equal to 2x is less than or equal to 6. Now we're going to divide by 2, and again, anything that you do to the middle, you now have to do to all your sides, right? You're going to do it 3 times. So we got -1 is less than or equal to x, which is less than or equal to 3. So this is going to be 2 dots, both closed, all right? 1 at -1, 1 at 3 with a line in between them. So the dots don't necessarily have to be the same, all right? If, for example, that wasn't there, then this dot would have to be open and the other one would be closed. But here they're both closed. And now we can write our interval notation with 2 brackets. We're going to be going from -1 to 3. So I hope this made sense, all right? If it didn't, you can always bring questions to class tomorrow. Oh, wait, actually. No, you guys don't even have class tomorrow. You can bring questions to class on Monday, all right? And yeah, we'll go over it again, but Hopefully this made sense. You can go ahead and work on the practice. And remember, if there's any questions you have on the practice, you can always look at the key. So I hope this was helpful. All right, bring questions to me if you have them. And other than that, have a great day.